Hello my friends, Gleb here and you're watching the Bevel tutorial from the 2.80 Plus update of hard surface modeling in Blender. So for the next 30 minutes we'll be exploring Bevel as a general concept in modeling, as well as the Bevel modifier in Blender, which allows for very interesting hard surface workflows, especially combined with the Boolean modifier. And generally speaking, we can assume that the Bevel modifier has become a substitute for the subsurface modifier, kind of, for the hard surface modeling workflows, which don't depend on the subdivision surfaces. And usually you end up entangled with these kind of bad topology issues after utilizing the Boolean modeling workflows, which are absolutely fine. You just have to add Bevel on top of it to make it work. It's also pretty useful for all kinds of paneling effects, especially in high poly situations. The rounded edges can help create separation between surfaces, or rather help emphasize this separation that is already there, and thus can help boost the readability of the entire model. And obviously no edges are perfectly 90 degrees sharp in real world. No edges converge at a single atom, and that's why Bevel can add realism to your models. Especially if you throw in the bevels of slightly different widths, and actually we'll talk about it in the tutorial. And one more thing that I wanted to mention is that even from the standpoint of mechanical design and engineering, bevels can serve as a heat expansion mechanism. So it makes sense even from CNC standpoint. And ironically, that extra bit of geometry information helps you create awesome shaders later on. But let's talk about the basics of Bevel in Blender. First of all, Bevel is just a modeling tool that you can find in the left panel that you can bring up by pressing T. The pros of using the tool over the modifier is that it's a little bit more direct and it's simply faster. You can just click on the edge, drag, then in the bottom left corner you can change the settings of the resulting edge. You can adjust width, segments and so on. We'll talk about it in more detail later on. So yeah, you can just change the settings on the fly, but when it's applied, you can no longer change anything because it has been baked in the geometry itself. So that's the con of using the Bevel tool. Let's take a look now at the Bevel modifier. Well, it needs a tiny bit of setup, and it has a lot of settings and all that stuff, but it gives you much more powerful and versatile workflow to play with. Because it's non-destructive, it doesn't alter the original geometry, and you can play with settings anytime you wish. It goes like this: you can tab into the edit mode, change the geometry however you like, and the bevel will still stay on top of all the changes you made. Or let's say we can just go ahead and add the Boolean modifier and just place it underneath the bevel. Or if you look at the modifier stack, it will actually mean that we need to place it on top of the Bevel modifier, but you got the point. The point is that the Bevel modifier should be the last one in the stack to make it work. So yeah, I think that shows the flexibility of this particular workflow. No matter what we do with the Boolean object, we still have the nice rounded edge on top of everything, and that's great. That means that we can alter the underlying geometry and still enjoy the benefits of procedurally generated smoothed out edges. And actually these two things, the Bevel tool and the Bevel modifier, are not mutually exclusive. We can just use both of them and relax. For some minor changes, for example, we may wish to use the Bevel tool. It's pretty cool that when we want to get an immediate access to vertices and edges, to inset it or do some other stuff. And it's also great if you want to tweak the normals, because the roundedness of the edge largely depends on the normals. So you may want to, for example, to rotate the normals. And by doing this, you kind of change the look of the bevel. And to be able to do this, you need to have the access to the geometry. And with the modifier, it's impossible. Before you apply it, you can do it only with the Bevel tool. So that's probably one of the reasons why you may want to use it, but that doesn't mean we cannot use the Bevel modifier on top of it for decorative purposes, or just to introduce this tiny little, almost unnoticeable rounded edge. Alrighty then. That's a brief overview of Bevel in Blender, and what I want to emphasize before moving on to different things is that the final look of Bevel really depends on the underlying normals. As we know, the vertex normals define the shading of the mesh, basically how it is rendered. So here we can see 4 models with identical bevel, but they look kind of radically different. So what's going on here? Let's enable the custom split normals, increase the size a little bit to better visualize what's going on under the hood. So even though the bevel width is the same and all other properties are the same, the custom split normals, the custom vertex normals are completely different. And in one case, the model looks faceted. In other case, it looks completely smoothed out. So that relationship between chamfered edges and vertex normals is something that we will explore in other tutorials from the 2.80 update. But let's just keep this in mind. Now let's move on to meat and potatoes, the bevel modifier settings. But before actually moving on, I want to show you a few tricks about using the bevel tool. Control B to bevel, that's the hotkey, and then you can use the mouse wheel to control the number of segments, and P, and then move the mouse to change the look of the profile. Now I'm gonna jump into the modifiers tab and add bevel. Here we have lots of different settings and even more in the upcoming versions of Blender, because bevel modifier is something that constantly receives the updates. So we can control the bevel on vertices if we enable only vertices checkbox, or edges if we keep this checkbox disabled. Probably the most often used setting is the width. It's simply, well, the width of the bevel effect, pretty self-explanatory one. To control the width method, we have a bunch of options.
Hi, 80 Burrows here. I thought I'd jump in and see if I could help make more sense on the different types of bevels we have available. Here's a graphic we've put together that hopefully sums it all up. I'll refer to this and then try to summarize what it means in a practical sense. For offset, that's the distance from the original edge, and it's probably the most predictable. In other words, all bevels are going to be the same size on the mesh. Extreme angles are fine, and faces either side of the beveled edge should remain the same size minus the bevel distance. For width, that's the actual size of the full bevel. This has less predictable results. All bevels are the same size on the mesh, but extreme angles can create large size differences in the faces on either side of the beveled edge. For depth, that's the perpendicular distance from the original edge. So this one's a little less predictable also, and the bevel sizes differ based on angles. More obtuse, softer angles create large bevel sizes, therefore creating large size differences in the faces on either side of the beveled edge. For percent, this is going to take the size of the faces on either side of the bevel edge and move the newly created edges that set percentage. So for example, 25% would take up a quarter of the overall length, and 50% would be peak edge. So no original faces left for any faces with a beveled edge on either side. It's basically all bevel. Either side of the bevel can be different sizes, so bevels can be less predictable, but the remaining face sizes are predictable. Angles aren't a factor, since this is based on edge lengths on the faces either side of the bevel. And that's all the bevel types that we have. So that wraps this section up. I'll throw it back to Gleb.
And here we have the clump overlap setting, which is pretty important. It means that when it's disabled, the bevel modifier will allow you to overdrive the effect and create edges which overlap. The next one is segments, the number of loop cuts created near the edges. Usually the magic number is somewhere near 3, a nice balance of manageable poly count and roundedness. I'm gonna right click and select shade smooth. Alright, so we can go as low as 1 segment, but it's usually a little bit too low. Like 10 segments or more doesn't make sense, because the poly count will blow up with no practical difference in terms of shading. Usually folks like Master Xeon and other hard surface gurus try to keep that number around 3. And the next one is profile. It just tells Blender whether the profile should be concave or convex. In other words, outdented or indented. In addition to other things, it's actually worth paying attention at how bevel profile actually affects shading of the mesh. Sometimes the higher values like 0.75 to 1 really help to fortify the shading, so to speak, to reduce the amount of rendering artifacts. But for the time being, I will keep it at 0.5, the default value. And what's next? Oh yeah, actually we can bevel individual vertices with the bevel tool. I forgot to mention it, so here we go. The hotkey is Shift-Control-B. Yeah, so it seems that we run into some kind of an issue where each additional edge makes everything explode. And why is it so? We will take a look at the moment. Let's just disable the modifier for a second. And go Control-Shift-B once again. Mouse wheel to control the amount of segments. And in the settings we can adjust the profile to make it concave. That looks right to me. We can adjust some other settings, but actually let's try to figure out why the bevel modifier played this weird trick on us. I'm gonna go over to the modifier settings and click on the monitor icon to enable the visibility of the modifier in the viewport. And yeah, we see the problem. Let's reduce the bevel width. So basically every edge got beveled, and to limit what edges receive the beveling effect, we can use various limiting methods. Angle is pretty simple. It means that only the edges that are, for example, sharper than 90 degrees or 45 degrees or whatever will get beveled. As a rule of thumb, only the sharp edges need to be beveled. Say the angle usually is greater than 30 or 60 degrees in some cases. Okay, so I'm gonna name this modifier bevel_angle. And I want to show a pretty important concept of working with multiple bevel modifiers, but first, let me enable auto smooth and set the angle. Right now it's 30 degrees. Basically, it takes the same approach, but instead of adding bevels at those angles, it instead sharpens the normals of those edges to give us the illusion of flat shading. And to reiterate, it'll only work if the cube is first set to shade smooth and object mode. It may sound confusing, but we will explore these concepts in much more detail in the normals related chapters. Now it's better. Now I feel much better. So let's add yet another modifier, or rather let's copy this one and name it bevel_weight. But instead of angle, let's choose the weight option. In Blender, each edge can have its own bevel weight, so this way we can control precisely how rounded the edges should be and what edges should receive the beveling effect at all. So I'm going to select this edge and press Ctrl-E to bring up the edge context menu and select edge bevel weight. And then just slide the mouse cursor to the side to adjust the width of the bevel. This time let's make it really wide, something like that. I think it looks nice. And because it's such a wide chamfer, we can play with segments a little bit. We can jack it up to 18 or something like that. Next, to drive it home, I'm going to copy the modifier once again and name it bevel_vertex group or something like that, because this time we're going to be using vertex group instead. This is the last limit method that we will discuss. Oh, that looks just like a flower. Wonderful. Okay, we need a vertex group. Let's add one by clicking on the plus icon. And as usual, it's a great idea to give it some name. So we can go over to the modifiers tab and select it in the vertex group drop-down menu. So basically what we can do now is control the roundedness of edges using the vertex weight. So we can select the bunch of vertices, or edges for that matter, and then in the vertex groups menu, we can assign a certain weight to it. In this particular case, I just selected the face to assign the weight of 1 to all the edges within the face. And obviously the bevel width is probably a little bit too high, so let's put it down to something like 0.14, whatever. And the segments, I think we can put it up higher. Okay, so now we have 3 distinct bevel modifiers in our modifier stack. The bevel angle should probably be the last one. So let's slide it down by clicking on these down arrow icons. It should be the last one in the stack because it operates procedurally based simply on the angle of the edges. Unlike other methods, it doesn't require any guides. So yeah, it just works. Okay, I wonder if you noticed that the shading is a little bit off. Like the flat surfaces show a little bit of a gradient. And it seems that we can simply crank up the segments to combat this issue. But this is really impractical. Look at the number of faces, almost 700 for a cube. And if we put the segments down to 1, we will notice that shading became way worse. But we can fix it by utilizing the new Hardened normals feature. It almost doesn't require explanation, it just works like a charm. But what it does, it weights normals based on their face weight. We'll definitely take a closer look at normals in other tutorials from the series, but for now, let's add yet another Boolean object. Ctrl- on the numpad to subtract, and in order to use this hotkey, we need to have the bool tool add-on enabled. And incidentally, this shortcut is used for applying the difference Boolean operation in the hardops add-on as well. Otherwise, we'd be setting all that stuff manually. Just check the Boolean related chapters and we are sure you'll understand. And if we want our bevel to actually show up, we need to make sure that the bevel angle modifier is put underneath. It's put as the last modifier in the stack, in other words. Some plugins like Hardops do it automatically, but actually I recommend trying to do that manually, especially if you have just started doing that type of stuff. Okay, now let's explore yet another setting of the bevel modifier, which is material. The polygons generated by the modifier can have a certain material associated with them and can have a certain material index for that matter. Just to quickly demonstrate this, I assigned like an index of 1, 2, and 3 to different bevels. And our default materials, for example, is white. And let's add the red one. So this is the index number 1. The blue one, that is index number 2. And finally the gray one. It's just the same material with slightly different colors, nothing special here. I'm still hoping that by the end of the tutorial a new notification will pop up, a new badge became unlocked, like totally unnecessary length of explanation, something like that. And I just keep fingers crossed that maybe you enjoy longer tutorials with ASMR. Okay, so one more concept of the bevel modifier that I really wanted to get across is that beveled edges help to weld two surfaces together. Like now, these two objects, the cylinder and the main shape, doesn't look connected at all. But if we add a little bit of bevel, and that means position the bevel modifier as the last one in the row, we will create an impression that these two objects are actually welded together or fused together. But the question is, how can we control only this tiny bit of bevel in between these two meshes? How can we do it? We just need another bevel, and we probably need to smooth out the beveled object to remove this horrible faceted look. So I'm selecting the main mesh, then I'm heading over to the modifiers tab, and I think let's copy the bevel angle, because we will use the angle method this time as well, but we can see that some kind of a problem manifested itself. The new bevel modifier just has conflict with the previous modifiers. What we can do to bypass it is actually tweak the angle, and instead of 30 degrees, let's use a greater angle. Maybe 60 will do the trick. There are no edges that are sharper than 60 degrees apart from this edge over here, so we can safely assume that if we set the angle to 60, it will just affect this edge. Wonderful, we can even add a few more Boolean cuts here and there, and rest assured that they won't be affected by the rest of the modifier stack aside from this particular modifier. And I can totally understand that it may seem complicated to keep all this information in mind. Like like this modifier should be 30 degrees, this 60 degrees, but it comes with practice, and as usual it's all about practice, yeah. Alright, and the next feature of the bevel modifier that I wanted to showcase is loop slide. Not that I understand it perfectly, but in some cases it just helps a little bit with fixing the mesh issues. For example, here I reverse engineered the loop slide issue that manifests itself when the loop slide is actually turned off and gets fixed once it's turned on. Look at this, some weird stepping issue that gets completely obliterated when you enable loop slide. And sometimes it gets better when you disable loop slide. So absolutely no guarantees about that, but if something looks off, you know what to do. Just try toggling this setting. Maybe it will help you work out the problem. Or maybe not. Ooh, so we're almost there, and yet another section of this tutorial. I just wanted to leave some room for shading issues, because that's really important. That never gets old, and I'll keep talking about that. So as usual, to be able to comprehend what's going on with shading, I will switch over to a shinier version of a matte cap, or really shiny like this chrome one. Basically, glossiness helps to reveal the streaks and other artifacts, and in some cases hardened normals doesn't really help. In most cases it does help though. It is magic after all, but in some it doesn't. And let's imagine, for whatever reason, is that we are limited to just one polygon as a bevel. So we're limited to one segment. So what can we do? Probably the first thing that comes to mind is go over to the Object Data tab and try tinkering around with the Auto Smooth angle. But even though it helps to solve this problem to some extent, it introduces yet another problem, which is faceted look. So definitely something has to be done with normals, right? Thankfully, we now have amazing modifier which does exactly that, which allows to weight normals according to some algorithms. So let's add the weighted normal modifier, and bam, the issue is gone. Let's now try to understand what actually happened. And in order to do that, I'm going to duplicate the mesh by pressing Shift D. Then I'm going to slide it over to the left and convert it to mesh. Remember how we have talked about the link between the look of the bevel and the normals and how they affect shading. So we can go ahead and enable the split normals display in the overlay settings. Let's select the face, the bigger one, and here you can see how good normals should look. And because this face is pretty big and prominent and flat, all the vertex normals belonging to this face should line up themselves with the face normal. And now I will show how bad vertex normals should look in this case. Alt-N, average, corner angle. So what this command does is that it averages the vertex normals of the selected faces. So you can see how from pointing up, the vertex normals go slightly askew. And that is not good. They should indeed be pointing up. Thankfully, that's exactly what weighted normals modifier does for us automatically, procedurally, based on the weight setting. And another link between these two modifiers, weighted normal and bevel, is face influence. See, within the bevel modifier we have a few options to control the face strength. We can set it to none or to new. That means new faces generated by the bevel modifier, which means just the bevel itself, or affected. That means the faces generated by the bevel modifier and also the faces that touch it, the faces surrounding it. Or we can set it to all. That means all faces will get respective face strength. So in many cases, by utilizing the link between those two modifiers, we can really enhance the shading. Alright, I think we have already mentioned hardened normals, the magical settings that automatically fixes everything. But let's pinpoint it one more time, just to make sure that we drove it home. So when the shading is bad, just press hardened normals. Yeah. After talking to 80, we pretty much agreed that alongside our next project, we'll really try to squeeze in a single or a music video featuring rubber ducks and all that stuff. That would be fun. Alright, one of the features that have been recently introduced to Blender, I mean to the bevel modifier, are miters. That means that in addition to other things, we can now control the miter patterns, the inner and outer miters. So in this example, if we actually tab into the edit mode and join this vertex and the vertex on the outer corner, we will create a totally different looking bevel at the intersection here. But actually, what if we dissolve this edge and leave it as it is, and instead try to control the pattern using the newly added miters? I will start off with the inner miter, the miter where the angle between two beveled edges is less than 180 degrees. And let's browse through the patterns and see how the various patterns look. This one looks just like an arrow. We can also try tweaking the outer miter, of course. If we set it to patch, we'll get something completely different. And let's see, switching the inner miter to sharp and the outer miter to arc produces the most beautiful topology in this particular case, in my opinion. It curves just beautifully. But that being said, different situations require different topologies, so to speak. But it's great that the new experimental features are being added to Blender. Almost, I'm tempted to say on a daily basis. But let's say very often, especially if you stick to the daily builds and don't wait for release candidate or even alpha. Okay, also the bevel miters can be used to experiment with the shapes like this one, sci-fi hexagons, or whatever it is. And speaking about daily builds and experimental features, there is a custom Blender build featuring custom bevel profile. I suspect that by the time you're watching this video, as usual, I just keep telling that, this feature probably made its way into the Blender trunk, into the main version of Blender. But yeah, it's cool that we can tweak the custom profile of the bevel modifier thanks to the developers of this feature. We can choose from a list of presets, like for example cornice molding and stuff like that. And I think that just makes the already great modifier a little bit better. You can even create crazy stuff like steps. But another small but useful feature is that in this custom build we can choose intersection type. We can make it grid fill, like the default behavior, or the cutoff. And that works not only with the custom bevel profiles. You can find this build on graphical.org, bevel profiles branch, or just wait till it gets integrated into Blender. I bet it will happen pretty soon, if not already. And yet another bonus thing that I desperately wanted to mention is the bevel shader. It doesn't directly relate to the bevel modifier and stuff like that, but it relates to the general concept of achieving round edges in Blender. So in the node editor there is the bevel shader, and we can plug it into the normal input of any shader basically to get rounded edges. Probably it's a little bit hard to tell because everything is very bright. Let's try playing with the settings of the material to make it a little bit more obvious. The base color, let's make it a little bit darker. Yeah, so now we can see that the edges, even though the model is pretty low poly, got a little bit of smoothed out effect. And what else? The radius can be tweaked, as well as the samples, which is pretty much the quality of the effect. So the shader is the other way of achieving beveling effect in Blender. And on this completely unrelated note, let's say that it pretty much sums it up. And I hope you enjoyed the tutorial. Understanding how the bevel modifier works, among other things, is crucial to understanding the basics of hard surface modeling workflows, especially those that involve the Boolean operations. So that was Gleb, Alexandrov. You're watching the 2.80 update, free update for the hard surface modeling video course for Blender. Keep modeling.